Hello everyone, today we'll show you how to perform a conditional logistic regression in R using longitudinal or panel data. This model has a few different names. It is also called conditional logit or fixed effects logit models. It is suited for your research question if you have longitudinal or matched data and that your DV is binary. For instance, your dependent variable is whether patients survived from a disease or not, and whether someone is in poverty or not. The data points are either 0 or 1 for your dependent variable. And you need to make sure that participants are repeatedly measured at 2 or more time points because the model will be doing within-person comparison. This model offers some special benefits, and the most interesting feature of the model is that all stable characteristics, even if they're not measured, are controlled as long as they do not change over time. For instance, stable characteristics are things like ethnicity and birth year. By conditioning out these stable characteristics, we can get rid of large sources of bias and confounding influence. On the other hand, these benefits are also limiting factors for the model. The conditional logistic regression will only look at within-person variation and ignores between-subject variation. Because of this feature, the model cannot estimate the influence of stable characteristics, but it will give you coefficients for variables that change over time, such as income and health. These independent variables in the model can be nominal, continuous, or binary. There are not a lot of restrictions about data types for the independent variables. Before we analyze the data, we need to make sure a few assumptions are met. First of all, everyone in the sample must have 2 or more measurements of the same dependent variable. Secondly, for at least some people in the sample, the values of the independent variables must change over time. Essentially, the model estimates whether the change in IV predicts the change in DV. And for this to happen, we need to have changes in these variables within person. And therefore, the model is going to drop everyone whose dependent variable does not switch from 1 to 0 or 0 to 1. I'm going to show you what this looks like in a dataset. Let's say we want to understand this question. Are teenage girls more likely to be in poverty after becoming a mother? We have ID numbers right here. This is the same person. From time 0 to time 1, this girl went from not being a mother to being a mother, and she went from not being in poverty to being in poverty. This person will be kept in the dataset. For participant number 2, she was not in poverty at either of these time points, and therefore her DV does not change, and our data will be dropped from the analysis. Basically, we want to understand what makes someone fall into or come out of poverty, and she cannot give us any information because she has never experienced poverty, and we are only doing within-person comparison, so we can't use her data. If you would like to learn more about the intuition and the math behind conditional logistic regression, I recommend checking out Allison's book. Before we go to R, and before I show you the code, I want to mention that the dataset needs to be in long format as opposed to wide format. Suppose we want to test this hypothesis that older adults who are younger at heart are more likely to be internet users. Our dependent variable is whether you are an internet user or not, and that is being coded as 0 and 1. The IV is subjective age, which is continuous. We have 3 control variables. They're chronological age, education, and subjective health. These 2 variables are stable characteristics, and like we discussed before, stable characteristics are automatically controlled and conditioned out of the regression. We cannot estimate a coefficient parameter for them, so we're just going to ignore them. On the other hand, subjective age does change over time, so we can put it in the model specification along with subjective health. We're going to do a complete case analysis. This means that people with any missing variables are taken out from the analysis. If your data are missing at random, there are some clever ways to salvage the observations. For more details, check out these 2 publications on the bottom. Moving on to R, this is all the code we need to run a conditional logistic regression, which is abbreviated as CLogit. You can also find CLogit in SAS and Stata, but R is free. CLogit comes with the library package Survival, And it's named survival because originally these kind of models were invented for epidemiology research, and those researchers were matching patients with controls to see what factors predict survival from illnesses. This is our dataset, and I'm going to show you what it looks like. It's a real dataset from the Health and Retirement Study. On the left here, we have subject ID. These are 2 observations from the same person. This is the independent variable subjective age, and the dependent variable is COM-EM, which stands for often used computers for email, web, and online shopping. And this is our control variable subjective health. From time 0 to time 1, you can see this person went from being an internet user to not being an internet user. And time 0 and 1 is actually 2010 to 2014. So in a span of 4 years, this person used to feel 60 years old, but only 4 years later, they feel 82 years old. So the model is going to tell us whether this change of feeling much older is going to predict this person's behavior of switching from using the internet to not using the internet. And moving on, this part of code here is going to get rid of participants who do not repeat twice. For instance, the first person here, we have data from them during baseline, but not during follow-up. We'll have to drop them. On the very bottom here, we have the model specification. It is saying whether you are an internet user or not is predicted by your subjective age and your subjective health. There are 2 control variables that we do not need to put into the model, namely actual age and education. This is because they're both stable characteristics. Remember, the unique feature of conditional logistic regression is that all stable characteristics are automatically controlled for. And the strata parenthesis allows me to tell the model that this variable is my participant ID. With panel dataset, we have at least 2 observations from each participant grouped by participant ID. Finally, I will run the model, and here we get the results. The sample size here tells us that there are over 600 observations from 300 participants. And the number of events is the number of times that the dependent variable equals 1. Because we deleted everyone with missing data and only kept those who switched from being an internet user to a non-user or vice versa, this number equals the number of unique participants we have in the dataset. And here is our independent variable subjective age. We do get a significant result, just slightly below 0.05. The fact that a coefficient is negative is saying that as you feel older, you're less likely to be an internet user. The exponential coefficient here is just another name for odds ratio, and it's going to help us interpret the coefficient. This number means that if an older adult feels 1 year older, their odds of being an internet user are multiplied by 0.98. So this aligns with the hypothesis that when you feel younger, you're more likely to use the internet, and when you feel older, you're less likely. On the bottom here, we have some test statistics for overall model fit. The pseudo R-square is 0.013, which is pretty low. The likelihood ratio test tells us that the current model is significantly better than a model that does not have any predictors in it. And this is the end of the video today. Thank you for watching and good luck with your project.